Hello everyone, I welcome you back in this course Introduction to Sequence Stratigraphy, and we will continue our discussion on the concept of phases. This is a continuation from our previous class where we have got the idea of definition of phases, the idea of Walther's law of correlation of phases, and the basic idea that phases indicates a particular depositional process, not the entire depositional environment. So now the question arises over here that how can we interpret about the depositional environment? Why should we do phases analysis? When we do phases analysis, basically over there we try to interpret all the processes going on in any sedimentary environment. For doing this particular practice, we commonly adopt another concept that I introduced in the last class, the concept of phases association. So, what is phases association? This is clubbing of the genetically related phases types within a particular depositional environment. As one particular phases will indicate a particular process. So, when I am clubbing genetically related phases types together, actually I am clubbing genetically related processes together in that particular sedimentary environment. So, those processes together will give us a much better idea which may help us for the interpretation of the depositional environment. So, that is why when we do phases analysis, the first step is identification of the phases and its interpretation in terms of the depositional process, and followed by that the next step is the phases association. So, to understand this concept of phases association, we can take one example over here. So, this is one picture, very schematic model of a delta system. There is a plan view of the delta system. That means we are looking from the top of the delta system, where this river system is flowing from this direction, and this is the marine part where this river is getting mixed up with the marine system. So, first we try to understand what are the major agent over here. Number one is the river flow, which is moving in this direction, which is flowing in this direction, and which is the main source of sediments in this particular environment. And the second agent is this marine basin where some marine processes are going on. To make it bit simple for our understanding, we can take just two major agents which are acting over here. One, the waves which are acting over there, marine waves, and the tidal currents. So, tidal flood current and ebb current. So, high tide and low tides which are going on. So, definitely as we know that waves, marine waves, they are restricted within the marine part only, marine basin only, because they cannot propagate into the continents or they cannot propagate into the rivers. So, the wave processes will be restricted over here up to this part, but tidal currents, since these are current, so they require a channel. So, they will try to enter through these channels which are actually the distributary channels of this main channel, and this tidal current will try to move in during high tide condition, and during low tide tidal current will try to come out, and along with this the river is continuously flowing and it is supplying water and it is supplying the sediments. So, with this basic idea, basic concept, now we can try to understand what are the different processes going on in different parts of this particular deltaic system. If I look at over here in this part, in this area, say for example, this area is beyond the tidal zone, beyond the zone of tidal influence. That means when tidal water is coming in during the high tide condition, it is coming or reaching up to this zone only, not beyond that. So, during high tide, tidal water is moving in this direction and it is affecting the flow, but beyond this zone we are not getting any effect of tide even during the high tide. So, in this part of the delta, what we are getting is entirely a fluvial system. Maybe once in a while when there is a very high tide condition, extremely high tide condition, maybe tidal water is coming in, otherwise this area is not getting any other influence. So, in this part what we are getting here is a simple meandering river system. What happens within a meandering river system? We get a channel, and along with that channel we get an overbank area, and within the channel we get some sort of point bars as the river is meandering. So, along the meanders we get development of point bars. So, what we can expect? We can expect formation of this kind of point bars starting from the channel lag deposits with development of large scale cross stratified sandstone units. Sandstones are quite coarse grained to medium grained, and then it is covered up by overbank areas where we get alternate sand mud depositions. Since these sand bodies are deposited through a flowing water, a current flowing through the channel, always we expect formation of current ripples, asymmetric ripples within the sandstone beds, and they may migrate to produce different type of cross beds, and they get alternated with this kind of mud which are indicative of the flooding conditions. So, in this part of the delta, we get one characteristic package of sediments. I am using the term package of sediments, which actually indicates package of facies or assemblage of facies. What are those facies? Number one is this sandstone body, which is a coarse grained sandstone having maybe trough cross stratified sandstone or maybe large scale planar tabular cross stratification, which indicates a very high energy flow condition, which is associated with some other sand bodies where the grain size is relatively finer, maybe medium size sandstone, and that is associated with relatively smaller scale bed forms, relatively smaller scale cross stratification with significant supply of mud resulting in climbing ripple cross stratification. So, another facies, and then we are moving into the upper part, which may be the part of the overbank or the bar top, which is formed during the flooding condition. There we are getting alternate sandstone, mudstone, sandstone, mudstone heterolithic unit, and each sandstone is characterized by a gradation from medium grain sands to fine grain sand with some ripple marks or a very small scale cross stratification. So, based on these different types of facies, what we are getting, we can define or identify 3 to 4 different facies types, and each of these facies types are characterized in terms of distinct characteristic properties which indicate a particular depositional process responsible for that particular facies. And when we club together these 4 facies types, what we get idea about the depositional processes going on in this part of the basin, because now we are getting idea from these 4 facies together that there is a channel with an overbank system. So, we can call that one as a fluvial facies association, which is forming part of the fluvial delta plane. But at this point, I do not know about the delta plane because I am just looking at only this portion. Now, coming to this next part over here, the condition is different. Why it is different? Because here the river channel is affected by tidal influences. So, the river flow is not exactly the same as it was here in the upper part. Here, every day during high tide, tidal water is coming in and it is obstructing the river flow. So, due to that, what we get different orientations of point bars, and within those point bars, we get signatures of tidal currents in terms of formation of tidal bundles, maybe deposition of some mud, maybe double mud drifts like this, maybe frequent reactivation surfaces. And not only that, when this high tide water is coming in, it is covering up the river channel, and many times water will flood over here. So, we get more frequent flooding events, and due to those kind of flooding events, very commonly we get natural levees formed over here along these zones. So, during high tide condition, water will topple over here, will spill over here, and then this water cannot come out during the low tide condition. So, gradually what will happen? We get a swampy condition developed in this portion, where if vegetation develops, commonly we can expect formation of coal or peat. So, these areas, they become frequent mud dominated areas, low energy condition with development of swamp and coal or lignite peat forming conditions may develop over here. Within the channels, what we are getting now, the bars will be less thick, the energy condition will be quite less with respect to this upper part, because here the fluvial current and the tidal current, they are obstructing each other, and that obstruction will lead to reduced energy condition. So, what we expect over here, we get relatively thinner units in terms of sand and mud, particularly the sand units, and those sands are characterized with tidal signatures. They are not pure fluvial sandstone anymore. And also what we expect is formation of more thicker overbank deposits. So definitely in this part what we are getting over here is another facies association. In terms of energy condition, in terms of depositional conditions, it is significantly different from this upper one. So here maybe we can call this one as the tidal delta plane facies association. Tidal delta plane facies association. Now when I am getting this tidal influence, I can understand this upper one, this fluvial one, it may be part of the fluvial delta plane part because these are all connected. So within this tidal delta plane facies association, I am getting say for example 3 or 4 or maybe 5 different facies types. Maybe one within the channel, one along these bars, one along the levee part, one along the overbank flooding area close to the channel, one in the overbank area in the distal part of the channel, and each of them having different conditions in terms of energy, in terms of flow. So their resultant products are different, the resultant facies are different. When I combine all these facies types together, what I am getting over here is idea about the tidal influence within the fluvial system, and that is giving me idea, that is giving me a clue that possibly I am looking at a tidal delta plane system. In the same way, if I move on to the next part, the delta front part, here the conditions are again different with respect to the earlier two conditions. In this part, it is no more a part of the fluvial channel, but it is now in the open marine part where the river system is supplying the sediments, and those sediments are getting trapped, mostly the coarser materials, and they are forming bars like this. Commonly we call them as mouth bars. So these mouth bars are forming over here, and from that mouth bar sediments are further distributed as per their grain size and as per the energy condition of the flow available over there. So these sediments which are supplied by the river will be immediately reworked by the wave or the tidal current or maybe both, depending on the energy condition of that particular shore area, and accordingly the mouth bars will get distributed along the shoreline. So definitely the conditions here are different and the resultant products are different. So the resultant facies types will be something different, completely different if I compare them with respect to the earlier two. So in this case again I can define maybe 3, 4 or 5 different facies types for example, and their characteristics will be completely different in terms of their properties, and definitely they will indicate different set of processes. When I combine these processes together, I can get idea about this delta front area, and the same is for the pro delta area. So this is the concept of facies association, where we are trying to look at individual facies types. Now just forget about this delta, just look at this succession, these logs. So in the outcrops, maybe they are occurring as this kind of vertical sedimentary log. So looking at this log, using the concept of facies, I can club this part as one facies association, I can club this part as another facies association, and I can club this upper part as another facies association. And from there, from this part to this, as I am moving upward, what information I am getting? That gradually the marine influence is decreasing and the fluvial influence is increasing. So definitely I am moving from a marine dominated condition to a fluvial dominated condition. Since on the marine system gradually the fluvial system is coming up, earlier the marine system was like this, and on that gradually the fluvial system is coming over. So definitely the fluvial system is progressing onto the marine system, it is moving forward onto the marine system with time, that means a delta is forming. So facies association gives us idea about smaller units, smaller portions within a larger environment. So we can define many number of facies associations from any sedimentary environment depending on our requirement, depending on in which scale we want to interpret about the depositional environment, and based on those grouping, based on those facies associations, we can get idea about the smaller units within the major or larger environment. So facies association actually gives us idea about the sub environments within an environment. Like in the previous example, within a delta we are getting facies association representing one sub environment like the fluvial delta plane, one sub-environment like the delta front. They are sub-environments within a larger environment, and from the phases association we can interpret about these sub-environments occurring within a larger environment. So, when we are looking at this kind of phases associations, we can think of some ideal conditions. Say for example, in the delta system that we have discussed, we can think of ideally this kind of things will occur, and for that ideal condition what we get is some ideal phases associations which are occurring one after another in vertical succession. So, when we try to interpret this kind of phases associations related to changing sub-environment conditions within an environment, what we try to generate is a phases model for that particular depositional environment. In practice, for each and every depositional environment, we know about a phases model, which indicates the type of sediments, the type of products that commonly are generated during the processes going on in that particular depositional environment. So, Walker in 1992 first proposed this concept of phases model with a vision that the phases model will provide a general summary of a particular depositional system. That means, if you have a deltaic system, then looking at one phases model, which is nothing but a vertical log, which will represent the major processes or the ideal processes going on in that particular depositional environment. So, it is the summary of the depositional system, summary of the delta depositional system, we will call that one as a delta phases model. So, a phases model infers the standard vertical profiles and the lateral changes of phases. So, when we try to define or construct a phases model, or when we try to refer to a standard phases model, where we have already considered that these are the processes going on or will be going on in a delta or in any environment, we try to compare that with our case. Say for example, we are doing work in one area where we are interpreting or we are thinking that maybe this is a deltaic condition. From the rock record, we are trying to interpret that. So, what we commonly do is we try to correlate that, match that with respect to the phases model of a delta. So, definitely the conditions in our case may not exactly be the same with respect to an ideal deltaic condition. So, there we have to be very much careful, because lot of natural variations in terms of changing allocyclic and autocyclic processes always affect the depositional conditions, always affect the depositional environments. So, if we apply this concept of phases model in a dogmatic way without considering this possibility of variations with respect to allocyclic and autocyclic processes, we may consider a major mistake, major error in our model. So, what is the application of phases model then? Phases model is a standard which we can refer. I am working in one area, and from that area I am getting certain data, certain inputs in terms of outcrops, in terms of core samples. So, I am doing phases analysis for that particular area, and from there I am trying to interpret the depositional environment. Now, at any point of time I can refer to that standard model. I am thinking of possibly as per the overall succession I am getting estuarine condition. So, I can refer to standard estuary phases model at any point of time. I can compare with that, but at the same time I have to keep my mind open that there might be variations, there might be unmatched conditions, unmatched portions where it is deviating or not matching with the ideal phases model. And we have to explain that why this is not matching with ideal condition, because that interpretation will actually make each and every case unique, and in nature each and every case, each and every environment is unique in terms of variations of processes, in terms of variations in terms of autocyclic and allocyclic mechanisms going on in that particular area. So, phases models are kind of standard that we can use for referencing purpose. So, definitely whenever we do phases analysis, we try to interpret about the processes initially in the local scale in terms of individual processes, which may be responsible for deposition of one facies, and then in a more collective way into more larger scale when we try to look at the facies association and we try to interpret about the sub environment, and clubbing them together into further larger scale about the overall conditions in the depositional environment. So, definitely there are different factors that control the nature and distribution of the facies, and understanding them in different orders, in different scales is very much important for proper interpretation of the depositional environment. So, what are those factors? Definitely the sedimentary processes. Sedimentary processes will control the products. Any change in the process in terms of the agent, in terms of the energy condition, in terms of the amount of transportation will definitely change the product. So, if you have a river system where water is flowing, change in energy in the water flow will produce different type of sediments, from fine grain sediments to coarse grain sediments in the basinal area. So, sedimentary processes are one of the key parameter, key control factor that will determine or decide that what will be the nature of the facies and what will be the distribution of the facies in different parts of the sedimentary environment or the basin. Second one is the sediment supply. So, what kind of sediments are coming in, which will depend on the source area. So, within this we can have two components. One, the kind of sediment or the type of sediments. What type of sediments are coming in? Maybe from the source area sand size grains are derived. Maybe from the source area only mud size grains are derived. So, in the product area, in the basinal area we will get mud deposition only, we will not get any sand deposition. And second one is the rate of sedimentation or the amount of sedimentation. If in the source area we have very hard rock where erosion is going on at very slow rate. So, in those conditions the supply of sediment will be very less, amount of sediment coming in, the rate of sediment supply will be very less. So, overall the sediment accumulation will be quite less. On the other hand, if in the source area you have very soft rock, like say for example a schist is there or maybe slate is there, so it will get eroded very quickly. Maybe some mudstone is already present there in the source area, a sandstone is present in the source area, so it will get eroded very easily and lot of sediment will be supplied into the system. So, rate of supply will be higher, amount of supply will be higher. So, when we are talking about the sediment supply, type of sediment and rate or amount of sediment supplied into the system. So, that will control what will be the resultant facies, what will be the nature of the resultant facies and what will be the distribution of the resultant facies. Third component is a very important component, sea level change. So, sea level change is one of the primary factor that controls depositional conditions and processes in a major part of the basins. I can give you just one small example over here. Say you have one basin condition like this where the sea level was like this. So, for this particular sea level, a river is coming up, maybe forming a delta at this part, and you have a river system over here. For this marine basin, you have the shore environment followed by the shelf environment. So, this is the shelf environment and this is the shore environment. Now, if there is a change in sea level, for example, maybe it is rising. So, due to that rise, sea will try to cover up this area. This rising sea level will try to encroach into the land and will cover up many coastal areas. What will be the result? This delta will no more exist, or maybe it will form somewhere here. This portion which was earlier a river system is now under sea, under coastal area, and this area which was earlier a shore is now under further deeper condition. The shelf which was earlier a shelf is now under further deeper condition. So, just this changeover in the sea level will entirely change the conditions in terms of energy, in terms of processes across this entire area. And when we have change in the process, when we have change in the condition, the resultant facies will change. Similar kind of example can be given for a falling condition. Say sea level is falling and it is coming over here, somewhere here. So, the depth over here in this part is decreasing and definitely the energy will be different with respect to the earlier one. And at the same time, now the river has more area to flow. because sea is going back. So, it is getting more area to flow and river condition will prevail. So, more erosions will prevail, more sediment supply will be there. So, all these things actually indicates change in the depositional condition, change in the processes, and those processes will result in change in facies, and together they will produce change in the facies association and the depositional systems. So, sea level change is one of the very important and primary factor that controls the nature and distribution of facies. In later classes, we will again come back with this particular point, the sea level change and its effect, and we will discuss about this in more detail with respect to two basic terms, transgression and regression. So, we will discuss about that in some future class. Next one is a climate, again a very important parameter, and it can have long term effect or it may have a short term effect. Short term effect, seasonal changes, monsoonal change, seasonal rains, melting of glaciers, little bit more warming during the summer. All these factors will change the process of erosions in the source area, supply of water into the system, supply of sediment into the system. In terms of long term, as we have already seen in case of Milankovitch cycles, that long term climatic changes will produce change in the sea level conditions, and that changeover will lead to eustatic changes or maybe local sea level changes, and that can have the same kind of effect as we have discussed in case of sea level change. And the last one is the tectonics, where we are dealing with the subsidence or uplift of the basin or maybe the source area. So, again this tectonics can have some local effect or can have regional effect. So, there can be some local tectonics within that basin where the basin floor is going down or the basin floor is going up. So, that will control local sea level changes, that will control the space which is available for the accumulation of the sediments, that will control the depth of water in that particular basin. If the source area is going up, it is exposed for more erosions, which will lead to more supply of sediments. If the source area is going down, erosion will be less, so there will be less supply of sediments. So, these are local effects, local changes in terms of basin scale tectonics, local scale tectonics, subsidence, uplift, and those changes will lead to change in the nature and distribution of the facies, as they will lead to change in the energy conditions. If I talk about the long term effect of the tectonics or larger scale effect of the tectonics, definitely it comes to the plate tectonic scale, and already we have discussed in our previous class about the cyclicities, different orders of cyclicities like the second order, third order sea level changes. So, they are dominantly controlled by tectonic forces like the formation of supercontinent, breakup of supercontinents, seafloor spreading. So, those processes will have a major effect maybe across the globe or maybe affecting a major part of the globe, changing the sea level across the globe, and that will again will have same kind of effect within the basin as we have discussed in case of sea level change. So, tectonics and climate have very important effect, a very important role to play in controlling the nature and distribution of the facies types, as they control the distribution of depositional environments in different parts of the basin or the type of basin, nature of the basin. So, all these are interrelated, interconnected with each other. So, for further reading on this particular topic, I suggest you to go through these books. So, to summarize now, in this particular class, we have tried to understand about the concept of facies association. We have tried to understand the different factors which control the distribution and nature of facies within a depositional environment, and combining these conditions, combining these resultant products, we do the facies analysis, and from there we try to derive facies models, which are nothing but some standards developed or derived for certain environmental conditions within a particular depositional environment, and that can act as a reference point, a standard which we can compare, which we can refer during our own work from individual basins. So, with this I will conclude this class. Thank you everybody.